Welcome to the Inquiry Oasis, the University of Arizona College of Education's podcast, here in the heart of the Sonoran Desert. We bring you conversations with our esteemed faculty members and staff whose research impacts lives from southern Arizona to the far reaches of the globe. We explore the transformative power of education in this border town, where diverse cultures and ideas converge, weaving a tapestry of innovation with compassion and a sense of wonder. So join us as we journey through the sands of curiosity, unearthing insights that enrich and inspire. Sit back and relax as we invite you to dive into the Inquiry Oasis. Thank you for tuning into the Inquiry Oasis. I'm your host, Jeffrey Anthony, and today we are joined by Dr. Kristin Gunckel, a professor of science education in the Teaching, Learning, and Sociocultural Studies Department here at the University of Arizona College of Education. Dr. Gunkel has a PhD from Michigan State University and a multifaceted career that spans teaching middle school science, working as an environmental educator, and a stint as a geologist. In her current role, Dr. Gunkel focuses her research on a range of intriguing topics, from environmental science literacy to the preparation of elementary teachers for science education. Her work often navigates the complex interplay between scientific knowledge and social justice, particularly in the context of the desert Southwest. She's been involved in groundbreaking projects like CompHydro, which aim to integrate computational thinking into our understanding of water systems, and is currently working on a research project titled Learning Progressions in Science 3, which is a partnership with the University of California, Berkeley. So, without further ado, let's embark on this journey of exploration and discovery with Dr. Gunkel here in the Inquiry Oasis. Dr. Gunkel, it is a privilege to have you with us.
It's great to be here. Thanks.
You're welcome. Before we explore the nuances of your research, could you share some insights into the formative experiences and motivations that have shaped your academic trajectory?
I don't think that becoming a professor of science education is on the list of careers that children consider when they're growing up. For me, the path to becoming a professor was marked by the doors that opened and the doors that closed as I moved through my life. I grew up spending a lot of time in the mountains of Colorado, and this instilled in me a deep sense of connection to the environment and also a love of rocks and the stories they tell about the earth. And this led me to study geology in my undergraduate and master's education. But when it became time to get a real job, I was not able to reconcile my environmental concerns with the job opportunities in the oil or mining industries that were available to me. The door to a career in geology was not one that I could walk through at that moment. So I turned to the education door, and I spent 10 years working in environmental education for museums and field stations in Oregon and New Mexico. After a while, I decided I needed to build a stronger teaching relationship with the children I was teaching than could be accomplished in the 1 day or 1 week events that I was doing. So I closed the door and walked through the door to become a middle school science teacher, teaching primarily elementary science, teaching primarily earth science. Unfortunately, this is a story about how teaching in the public schools became untenable for me personally. But just as I was in my darkest moment in my career, another door opened into academia, and I walked through it and have never looked back. Today, I get to conduct research about topics and issues that are meaningful to me, where my work hopefully contributes to a deeper understanding of the world. I get to teach young people about how to teach science in elementary schools and mentor new researchers in our profession. I would never have predicted this path for myself, but this is where I grew up and am enjoying it.
Well, that's a fascinating story. Thank you for sharing with us. So now you recently completed a project called CompHydro, which delved into the computational thinking as applied to water systems. Could you give us an overview of the project as well as talk a bit about the computational thinking and why this aspect of scientific thinking is so important for students and the general public?
Yeah, this was a really fun project. I worked with colleagues from institutions in Montana, Colorado, New York, and Maryland to develop curriculum materials for high school science that integrated computational thinking into learning about water. Our goal was to help students use computational thinking to understand locally relevant water issues. Our Arizona curriculum focused on the TCE, which is trichloroethylene, and 1,4-dioxane contamination of the groundwater near the Tucson International Airport that has so adversely affected the populations on the south side of Tucson. This is a situation that has been going on for nearly 70 years and was the result of the use of TCE and 1,4-dioxane to clean airplane parts at the airport when the Air Force was putting planes back into service. The chemical degreaser was dumped onto the open desert and eventually infiltrated into the groundwater. The water contaminated the drinking wells of many families, many of whom were of Mexican descent. And decades later, clusters of autoimmune diseases, cancers, and dental issues were discovered in the area and traced back to the water. At first, the city denied any responsibility, but eventually the community organized and after years of legal proceedings won a dissent decree that led to the designation of an EPA Superfund site to clean up the water. Today, the TCE and 1,4-dioxane have mostly been removed from the water, but there are new concerns about other chemicals, such as the PFAS chemicals, also known as the forever chemicals, that are in the water. Our position in this project was that understanding how the groundwater got contaminated, how we know where the contamination came from, and how it moved through the ground, as well as why it was there in the first place, is knowledge that was and is essential for cleaning up the contamination. The community members who won the consent decree had to learn the science behind what was happening, and they did, and that knowledge was empowering, and they used it for justice. But the thing about studying groundwater is that it's hidden. You can't see it. So how do you know where it is, how deep it is, how fast it's moving through the aquifer, and what's in it? Well, we have to drill wells to sample the water, but wells are expensive, and they have impacts themselves. We can only drill so many wells. So we have to make inferences about what is happening underground. And that's where computer models come in. We use computer models to figure these things out and predict where the water is going. But not all computer models are created equally. Just because someone uses a computer model to figure something out doesn't mean that that's exactly what's going on. It's still an approximation. So a person needs to know how computer models are built and how to understand and critique and use the answers that computer models provide. So in CompHydro, we built special versions of groundwater models to help students understand both what groundwater is and how it moves through aquifers, and also how computer models are used to figure out that information. Our hope was that students would become critical users of computer models, or more likely the output from the computer models, asking such questions as, where was the data gathered that went into this model? Does this model really support what we are noticing? Does the model really support the claims that are being made? This understanding can then empower students to understand and take actions on the main issues related to water that affect their families and communities.
That's really incredible to be able to empower community members to understand that the models that are giving them outputs are not necessarily neutral, that there's actual decisions that go into that, and that you can critique those decisions. That's incredible. We also are very curious to learn more about the project you are currently working on, and that's in partnership with the University of California, Berkeley, called Learning Progressions in Science 3.
Yeah, speaking of models, learning progressions are also models. They're models of how students learn about a science topic. They connect how children first think about a topic with scientific ideas and show how children's ideas change over time as they move through school. They can be useful in aligning curriculum, instruction, and assessment so the students have a much more coherent experience learning about science. The LPS project, Learning Progressions in Science project, has been building learning progressions for a while. They've been looking at such topics as structure of matter, ecosystems, and the science and engineering practice of argumentation. In the current iteration, which is why it's called 3, they brought me on to help them build learning progressions related to earth science and specifically about water. In one of my previous projects, I had worked on a learning progression for water in environmental systems, specifically the water cycle. So I wanted to do something that hadn't been done yet, and that was how students think about water as a limited resource and the impacts that human actions have on water in terms of both quality and quantity. So that's what we're working on right now. We're making good progress, and we still have a couple years to go on it.
That's fascinating. Let's bring this back to our institutional context. And I was wondering if you could articulate why this research is salient for the University of Arizona community, especially given the desert Southwest environment.
When I was teaching middle school, I had a saying that was posted above my chalkboard in my classroom, and it really was a chalkboard. The saying was, we all live downstream. Water connects everything on this planet. What we do with it and to the water affects us and everything that lives on the earth. Earth is the water planet. 70% of the Earth is covered with water. It is a life-giving force, and yet today we treat it as a commodity that is to be used, bought, and sold. Our use and abuse of water has dire consequences for us as a species and for the other species we share our home with. Therefore, much of my academic research focuses on how we can come to understand where water comes from and where it goes, what is in it, and how we use it. This includes how human, social, cultural, economic, and political systems are intertwined with water. We live in a desert where the relative scarcity of water is visible, but the connections we have to water are universal, and the issues that arise related to our connections to water may play out in local context, but they are all globally relevant.
In light of increasing climate change concerns, you are also venturing into climate change education. What are some pedagogical strategies you envision for preparing students to effectively educate about climate change?
Yeah, climate change is such a pressing issue, and it's also an overwhelming and often depressing topic. I really believe that schools have an obligation to prepare our children for the world that they will live in, and today we can't really be sure what that world will look like, even 5 or 10 years into the future. Our youth are extremely concerned about this, but at the same time, climate anxiety is a real phenomenon that leads people to deny or disengage from the important conversations that need to be had and the important actions that need to be taken. Furthermore, our young teachers are feeling like there's not much they can do or they don't know what to do. There are few guideposts out there. My approach is that we need to use ethics of care and pedagogies of hope. That is, we need to acknowledge the pain, the injustices, the trauma caused by climate change. Teachers need to be able to support their students in learning to adapt and survive in a changing world. But how do you do that when you yourself are anxious and concerned and potentially traumatized by the impacts of climate change? This is where hope comes in. Hope is more than wishful thinking, like, I hope that it all gets better. What I'm talking about is transformative hope. Transformative hope is an instrument of social praxis. It's a sharing with members of a group, and through this sharing, change becomes possible. So I look at the recent case of the Montana youth who won Held v. Montana, the court case that affirmed their constitutional right to a healthy environment. That was an example of people really coming together to make change happen, and that is inspiring.
Indeed. In your work, you focus on the often overlooked aspect of creating equitable science education for the LGBTQIA+ community. Could you discuss how elementary science education can serve as a platform for both equity and social justice? And additionally, how can we prepare elementary teachers to be effective advocates for inclusivity and diversity in the realm of science education?
Elementary science is not often recognized as a place where social justice work can be done. Many people think of science as just objective facts. But elementary science instruction is absolutely a place where we can do equity and social justice work. One way to do this work is to expand for teachers and students what counts as science. By this, I mean that there is often a rather narrow view of what science is and who can do it. When we bring in multiple perspectives on sense-making and how the world works, we find out that our limited views of science prevent us from learning new and amazing things. For example, school science tends to portray all organisms as having only two sexes, either male and female, with very specific differences and roles relative to each other. But a book by Joan Roughgarden, a biologist and a trans woman, called Evolution's Rainbow: Diversity, Gender, and Sexuality in Nature and People, documents the remarkable gender and sex diversity of the natural world. For example, many species, such as the mockingbird, do not exhibit sexual dimorphism. Both males and females look the same. In some species, such as the clownfish and bluehead race, individuals can change sexes during their lives, while in other species, like the hamlet fish, both sexes are present at the same time in the same individual. Bears and pigs can be intersex, meaning they have characteristics of both sexes. The sexes of reptiles, like painted turtles and crocodiles, is determined by the temperature of their eggs at incubation. And furthermore, not all sex roles are the same. Male seahorses carry and raise young, and male penguins are primary caregivers. Not all reproduction is heterosexual either. Female whiptail lizards, for example, can clone, meaning they don't need males for reproduction. In elementary school, we can use these examples to show that the world is not simply divided along a binary into two sexes, and that there is instead an incredible, beautiful, and wonderful array of beings that expand what is seen as natural. And another place we can do equity work in elementary science is by strengthening the visibility of LGBTQIA+ identified scientists and their work. Just as it is important to recognize and celebrate the contributions of scientists and engineers who identifies people of color as mechanisms for breaking down stereotypes about who can do science, making visible the contributions of the LGBTQIA+ community to science and engineering can similarly increase positive visibility. Examples include scientists who may already be celebrated in elementary schools, such as Rachel Carson, a marine biologist who inspired the global environmental movement, George Washington Carver, the former slave who revolutionized agriculture and was also likely bisexual, and Sally Ride, the first woman astronaut in space and also the first LGBTQ person in space. Alan Turing, a British computer scientist who likely saved the Allies in World War II with his work on computing machines, is another famous example. And there's even evidence to suggest that other famous scientists, including Francis Bacon, Isaac Newton, and Leonardo da Vinci, were not heterosexual. So including LGBTQIA scientists and engineers as science role models not only increases the visibility of LGBTQIA scientists and engineers, it also normalizes what it means to be LGBTQIA and who can participate in science and engineering.
Wow, that's incredibly important work. During the course of your research, have there been any discoveries or outcomes that took you by surprise?
I wouldn't say that there were things that have been totally unexpected, but I do enjoy getting a window into how children think about science. Kids are always making sense of their world, and it is important for educators to understand how children think about things. One of my favorite examples is how children sometimes think about where water comes from and where it goes. In my research, I have had kids create drawings of where they think their drinking water comes from and where it goes when it goes down the drain. Often, kids will draw a pristine mountain lake as a source of their water, nice with lots of trees and no people, just a nice, pretty picture. And they'll draw a pipe from that lake to their house. And when asked where the water goes after it goes down the drain, they'll draw the pipe from their house to their neighbor's house. So their own water comes from a clean source, but their neighbor gets the dirty water from their house. But you can see why this might make sense to a young child. They know that there are pipes underground and that the pipes connect the houses. But we can use this understanding as a starting point for helping them learn more about these important systems.
So, if you could leap forward in time and observe the future of science education, from environmental literacy and water systems to the preparation of elementary teachers, including their ability to create an inclusive and equitable classroom for all students, what transformative changes or innovations would you be most eager to witness?
If I could have one thing that I would want to see the most, it would be that there be more science taught in elementary school. Science is one of the forgotten subjects, which is too bad because kids are very interested in science and eager to learn about it. They have so many questions, and science is one place where we can make school relevant to their lives. It is also a place to integrate many disciplines, including mathematics, reading, writing, and social studies. And so emphasizing science more in elementary school could do a lot for increasing science literacy in general.
Indeed. As we near the end of our conversation, we like to ask our guests to recommend a book or paper that has been meaningful to them. Could you share one with our audience and explain how it has impacted you?
Yeah, there's so many books, right? I'm sure everybody says that. But one book that I read recently that really impacted me was The Book of Hope, A Survival Guide for Trying Times by Jane Goodall and her co-author Douglas Abrams. Someone gave me that book and said, "Here, you have to read this," and they were so right. This is a book that really got me thinking that there could be hope even when it seems like there is no hope. When I was in college, Jane Goodall came to speak at the university where I was studying, and I was so excited to go hear her talk in person. She was inspiring then, and now, all these years later, she is still inspiring. I share this book with my students, and many of them have never heard of Jane Goodall, but after reading parts of the book and learning more about her amazing work, they are inspired too. Everyone should read this book.
Well, I will second that. We own that book at home. My wife has just finished it. It's on my nightstand table, so it's up next. Thank you for that recommendation. And Dr. Gunkel, our time today has afforded us a rich exploration into your scholarly work, which spans from environmental literacy to the realms of inclusive pedagogy. Your contributions are not merely academic, they are an urgent call to reshape the fabric of science education for a just and sustainable future. We look forward with great interest to your ongoing work in these vital areas. And thank you, listeners, for joining us today in the Inquiry Oasis. We hope our conversation with Dr. Gunkel has inspired you as much as it has us. And remember, we're back on the first and third Wednesdays of every month with fresh insights and conversations, so be sure to tune in. And until next time, keep your curiosity alive and remember, knowledge is our oasis.